Topic 8-5, more with dividing radicals. This can be referenced in our Holt textbook, Chapter 11, Section 8, starting on page 816. But I want to go over first, you'll want to grab a calculator to do these topic pages. It needs only to have a radical symbol on it, where this one is right here on the x squared. To access that radical, we hit the second button. On the TI-83s, that's a yellow button. Okay, so what I want to go over first is a common mistake, and that is common errors that happen in multiplying radicals is that the students take the 5 and multiply it, the whole number, and multiply what's underneath the radical. This is called the radicand. If this is multiplied together, you get a square root of 16. I'm going to say 16. I think I was looking at that. Square root of 10. Well, if you'll come over here and put square root of 10, then notice how in a radical they put a parentheses. It's probably a good habit to go ahead and close the parentheses. And the parentheses button's right there. That's going to give you approximately 3.16. The right answer for 5 square roots of 2 would be to show it this way. 5 second square roots 2, close the parentheses, is definitely a whole different number. They're not a match. It's 7 and 7/100ths. So be real careful. You cannot multiply what's on the outside of your radical sign with what's on the inside. So make sure you're keeping all of those separate in your answer choices. But we're going to use a calculator to check all of our answers for this topic. Look at the first one. Because I know that I can divide 20 by 3, then I'm going to put the entire numerator and denominator radicals into 1. So you can make it a big radical symbol and show it to be 24 divided by 3, which is a square root of 8. Actually, this simplifies even further. I'll keep using the same one. Square root of 8 is a 4 and a 2. We know that a 4 has a perfect square, a pair of 2's. So actually, square root of 8 is 2 square roots of 2. Just remember that whatever pairs that are circled go to the outside of your radical. What stays under, we've gotten in the habit of boxing. Okay, so that your answer for this is 2 square roots of 2. But you can check this. We'll get out of that. Clear your calculator. We're going to clear that, and we're going to put in, for this one, second square root of 24, close the parentheses, divided by second square root 3, close parentheses. That's 2.82. Well, we're going to check to see that we did our answer correctly. If you put in 2 square roots of 2, you should get the same decimal value. So as long as you're getting the same decimal value, you should be able to make 100 in this section, because once you've figured it out, your simplified answer, check it with the original answer to see if you get the same thing in a decimal value. Okay, we did a little in topic 8-4, and this is just a repeat of remembering that you will multiply by a product of 1. Sometimes I put this in a parenthesis because you need to realize that a square root of 35 over a square root of 35 is just 1. That is a product of just 1, the value of 1. So if I multiply anything times 1, all I'm doing here is changing the look of it, but the value will still be the exact same. So in this case, square root of 35 times square root of 35 gives you just 35. Rationalizing the denominator means getting the radical away from, not in the denominator. Square root of 14 times square root of 35, you multiply 14 times 35. That stays under a radical. But we know that 49, I can see that that's a perfect square. It just has a power of 10 multiplied to it. So I can't forget about this 35. But right now I'm just looking at the numerator. So I've drawn my arrow here. I'm simplifying this expression, or this radical here. So 10 times 49 is a pair of 7s. So we know that that pair of 7s factors completely to the outside of my radical, where the 10 stays underneath. That's where I get 7 square roots of 10. But don't forget that what was in the numerator I need to carry down and keep in the numerator. So 7 square roots of 10 and 35, well, this reduces. Get pretty colorful with my reduces. 1 times 7 is 7, and 5 times 7 is 35. I don't normally put a 1 here, so square root of 10 divided by 5. Let's check our answers. If I have square root of 10 and I divide that by 5, I get this answer. Let's go back to our original problem and say second square root 14, close the parentheses, divided by square root 35. See how I get my same decimal answer. So I know I've done the problem to its simplest form because I cannot simplify that radical any further, and yet it is the exact same answer in decimal value, checking it with my calculator. So with these problems, we're going to do 4 more. I want you to check each one of them with your calculator. Okay, again, we're going to multiply this by a product of 1. If it helps, highlight it. Because when I multiply by a product of 1, this rationalizes the denominator. Square root of 12 times square root of 12 is 12. 2 times square roots of 12. Don't multiply 2 and 12. That's under the radical, so it stays under the radical. Now be careful here, because what I'm going to do is I have to simplify just the square root of 12. So I'm going to highlight what square root of 12 is. But don't discount that I've got to keep my 2 in my problem. So the 2 stays here for now. So 12 is 2 square roots of 3. Why? Because 12 is 4 times 3. And then 4 is a pair of 2's. The 2 moves outside the radical sign. The 3 stays under the radical sign. So study that closely. This is the simplified form of a square root of 12. Okay, and then this denominator stays the same. Then I have to multiply this, and this is 4, and this is 12, so this stays as the same, but 1 times 4 is 4, 3 times 4 is 12. So 4/12 simplified to 1/3. If that's confusing to you and then you can do this. You can know that this was a 4. Your denominator, this means to divide, was a 12. 4 divided by 12 is decimal point 33333. If you hit the math button here, enter, it gives you back the fraction. That's understood to be a 1/3. I wrote it like this, but the exact same answer could be written like this, 1/3 square roots of 3. Those actually mean the same thing. You're going to see it written in this form, though. Check it with your calculator. 2 divided, oops, let's curl this out. 2 divided by second square root of 12, and second square root of 3, close the parenthesis, divided by 3. You should get the exact same decimal value. That way I know it checks out. It checks out to be the exact same thing there and there. Alright, rationalizing the denominator for number 4 means to multiply it by a product of 1. I've been highlighting this. When you multiply, it becomes 20, and 25 square roots of 20. Don't multiply them together. Be careful to keep them separate. And then I'm just showing what the factorization, what was that? I highlighted that in pink. Not the factorization, but the simplified form of square root of 20. Well, the simplified form of square root of 20 is 2 square roots of 5, because 20 factored is a pair of 2's that factors outside the radical. The 5 stays underneath the radical, But then that 2 has to be multiplied by, don't forget that we had a 25 up there. The 25 has to be multiplied by the 2. These two numbers multiplied together get you the 50. It's very, you got to do this very neatly or you possibly will mess up. 50 square roots of 5 divided by 20. These two zeros go away, so that's 5 halves. But you got to keep your square root of 5. Check this answer with your calculator. Put this answer in your calculator. Then go back and put this answer in your calculator, making sure you put parentheses where your radicals are, and you should get the exact same decimal value. So make sure you do that on your problems. I'm not going to do it for every single one. Okay, number 5. 18 divided by 3 square roots of 2. Well, 18 divided by 3 is 6. And, oh, you know what? I did that wrong. That's 6, but the square root of 2 doesn't move up to the top. This actually stays in the bottom. So that's wrong. It's 6 over square root of 2. We want to rationalize that, so that's square roots of 2. Square roots of 2. You're multiplying by the same. Alright, so that becomes 2, and the top is 6 square roots of 2. But this reduces. 6 divided by 2 is 3. 3 square roots of 2. So make sure you check this with your calculator to see if it's the same thing as that. Wait a minute. 6 divided by square. How could that be? Maybe I've done something. 2, 6. No? Interesting problem. I gotta check that. 18 divided by 3 second square roots of 2 and 3 second square roots of 2. I've done something wrong. Teachers make mistakes too. Okay, wait. This would be 1. This is 6. 6 over square root of 2. 1, 3. Give me a minute to look at that again. Maybe that 18. Maybe I have to put this in double parentheses. Maybe I'm learning something myself. Second square root of 2, close parentheses. You have to actually put 2 parentheses because that one's there. Ah, it is the right answer. I don't know why I'm thinking of several, but this is actually good to have shown this because notice the difference. This really is the same thing, but you can't say 18 divided by 3 because it's going to do that operation first. Order of operation will divide 18 by 3, and then it will multiply by a square root of 2. So that's why that one ended up being wrong, because you're really dividing 18 divided by the whole thing, which the whole thing is the same thing as that. It made me question it because your answer ends up having a very interesting answer, because your answer has something that's in the denominator already, so it surprised me that it could end up even being the same answer. But it is. Okay, and number 6, I'll let you pause this and work through that, but check, make sure that your answer is the same as what I've boxed as your original problem. So if you need to, if you need to, make sure that you remember that everything I've highlighted in green, that's rationalizing the denominator. You'll use this again in dealing with formulas and geometry, so make sure that you get this understood before you move on. That concludes topic 8.